One of our batteries we had a problem with. It was leaking, and we're looking to get a replacement. So we opted to only implement one of the comparators at this time, and it will work correctly without the second one with a little bit of modification to the circuit. And once we eventually get the second battery, then we could change the circuit back and then put it on. And I opted to make the comparators modular, so it's on a daughter board that connects onto the rest of the logic, just so that we can troubleshoot easier. And the batteries we used, it's a pack of 5 1.2 volt batteries, rechargeable, and it will get supplies with 6 volts that we need. And we did have a problem with the supplier, and they sent us nickel metal hydride as opposed to nickel cadmium. But whereas this is just a prototype, it will work for our purposes.
Okay, and for the purpose of controlling timing the device and also to controlling the IF transmitter, to send a station, we use a microcontroller. This is the one we use. The board we use with include MSP430 and is another chip CC2500, which is the IF transceiver, and the board can operate in very low voltage and drain a very low amount of current, which is very high power efficient. Also can withstand the range of temperature that we desire. This is the block diagram of the board, and basically there's a pin 1 to interrupt, which is connected to the output of the switch and the sensor, so that we can detect if the passenger is there. And we also use a timer to timing how long the passenger has already sit there. And we use SPI in order to communicate with the IF transceiver, and we control the IF transmitter by using the controller. And we use the IF transceiver CC2500. It have output. It can supply. It can send radio frequency at 2.4 gigahertz, and it train very high current, but it's only needed to transfer when the alarm went off. So it doesn't train the current when the alarm is not going off, and it's interface controller, and as well the data transfer rate is about 500 kilobyte. This is our diagram of how the system works. So when the whole system initialized, and then it will go immediately to sleep mode, and so that it doesn't drain a lot of current. And once the proximity sensor send a signal showing there's a passenger, and the ball will activate it, and checking every 1 minute if there's a passenger is there. And after 15 seconds, so that we wait for the passenger to sit on the chair and then we check if the bar switch has been closed or open, and then we will activate the audible alarm after 15 seconds. And after the audible alarm went off, we will go to sleep mode, and then after 15 seconds we will check it again to see if the passenger has been lowered the bar down, and if not, we will send a signal to the station using the IF transmitter. And our product result is it works, and the battery is able to supply the device for 8 days without sunlight. And this is our unit cost. So the two most expensive part is the sensor and the solar panel, which is cost a total of about $30, and our unit cost about $50. And our break even, as you can see from the chart, is about 1200 unit. And this is our cost analysis. We expect from this is the expecting units sold in the course of 2.5 years. So we don't expect to sell any product from the first 2 quarters, and then we expect to sell increasing. And this is our cash flow. So after year 1, we're expecting to gain profit, and the profit margin is about 60%, and the return on investment is about 40%. and we're gonna demonstrate. And for the first demonstration, we set the waiting time for only 5 seconds.
Okay, and so what it's going to do is we have one microcontroller transmitting, and then we have another microcontroller hooked up to the computer right there that will receive, and it will send a signal. Right now we have it set to say the chair. I believe this one's labeled 10. Each one has a unique ID. Has their bar up, and this is something that software could be written off of that a terminal operator could use, and it will notify them when the passengers are not properly riding.
If that's not ready right now, we can save that for the end. You need to get that up and running.
Okay, so that
Is that a
Send a
transmitter?
signal to them. They should just.
Is it working now?
So
Okay,
the
so
red
right now
LED right there
it's
means that someone's sitting in the chair, but the alarm has not gone off. And
Mhm.
once the green LED goes on, the audible alarm should go on. I don't know, can you hear it?
Can't hear it now. No. But the reason why it is sensing right now is because the sensor has quite a wide range, and I'm standing very close to it, so it assumes that I am in the vicinity. And a chairlift is usually very wide, so that would be something that we would need.
Is it blinking now?
yeah, you can see from this is IF receiver, so you can see the green light blinking, which means this one is sending us fire signal to this one.
And then you can see a message on.
Yes.
Well, usually you can see a message on here that says like chair 10 has not put their bar down, or chair whatever. Depending on how many microchips we have, they can each send out a unique signal with a unique message. So if we say chair, number of chair has not put their bar down.
And then once they put their bar down, it should deactivate the system, which it has, and now they are no longer sending an RF signal. And
So I don't see the green light.
Yeah.
Can you put it back up and we can start transmitting again?
After maybe.
yeah, after a
20
certain amount of time.
seconds.
So come back up, and now it's starting to pull.
We gotta wait on that.
Yeah, this is
Okay.
green
All right,
light.
we don't have time for questions. Sorry.
Yeah.
Okay, very good. I just have one comment. A number of times you said you a lot more to implement to finish. We only have like less than a week left, so I would caution you and say it's probably good enough for the purpose of this course. I don't want you to fail 2 other classes to pass my course. Okay, so I have seen some MPP projects with less than what you tried to implement in 7 weeks. You know, so it was an